Design of HBase. Preface. Content of this lecture. In this lecture we will discuss what is HBase, HBase architecture, HBase components, data model, storage hierarchy, cross data center application, auto sharding and distribution, BloomFilter, folding, fold, store and shift. So HBase is an open source NoSQL database. This is a distributed column oriented data store that can scale horizontally to thousands of commodity servers and petabytes of index storage. Because this amount of commodity machines or the cluster is required to store the large amount of data. That is why this particular aspect is covered into the distributed column oriented data store, and also it can scale out horizontally to thousands of servers and petabytes of indexed storage. HBase is designed to operate on top of HDFS for scalability, fault tolerance and high availability. HBase is actually an implementation of Bigtable, which is a storage architecture given by Google, and this is which is a distributed storage system developed at Google. So HBase works with structured, unstructured and semi-structured data. So HBase is basically designed as the Google's Bigtable, was first blob based storage system, and Yahoo open sourced this particular concept, blob based, and which is now known as HBase. So HBase is a major Apache project today, and Facebook also use HBase internally, and it has various API functions which provides, for example, get and put by row, that is the key value pair, and scan the row range and filter all these operations which are supported to perform the range queries. It is also having a multi-put, so that multiple key value store can be handled at the same time. Unlike Cassandra, HBase prefers consistency over availability. Now Cassandra prefers availability, whereas HBase prefers consistency over availability. So now we are going to see that wherever consistency is a preferred option for the application, HBase is used, and wherever availability is more important than Cassandra is used. That is why both of them exist as the NoSQL solution. Let us see some of the important aspects of HBase architecture. So HBase has the region servers, and these region servers are basically handling the regions, and there is one HBase master, and this zookeeper has to interact with the HBase master and all the other component, and HBase then HBase also deals with the data nodes. So HBase master has to communicate with the region servers and zookeeper. So we will see in more detail about this. So HBase architecture, here the table is split into the regions and served by the region servers. So regions vertically divided by the column families into the stores. that we will discuss later on. And stores saves as files on HDFS, and HBase utilizes Zookeeper for the distributed coordination service. The components in more detail. So, client will find the region servers that are serving particularly the row range of interest. So, then HMaster monitors all the region servers instances in the cluster system, and regions are basic element of availability and distribution for the tables. Region servers serving and managing the regions, and in a distributed cluster a region runs on the data node. So, this is the typical layout of the data model, which is also called as the column families. So, data is stored in HBase is located by its row key. So, row key is the primary key from the notion of relational database management system. So, the records in HBase are stored in the sorted order according to the row keys, and the data in a row are grouped together as the column families, and each column family has one or more columns. These columns in a family are stored together in a low level storage file, which is called as a H file. So, the tables are divided into the sequence of rows by the key range called the regions. So, here we can see that this particular key range is basically nothing but the row 1, and this will be stored together into the region. So, these regions are then assigned to the data node in the cluster called the region servers. Now, that is shown over here. So, again for the example, let us say that the range the sequence row, the key range, the row key range R2 will store these set of the rows, sequence of the rows, and this will be stored in another region server, and the region servers, these regions are managed by the data nodes. They are called the region servers. Region servers as the data nodes. Now, column family, a column is identified by the column qualifier that consists of the column family name concatenated with the column name using the colon dot x personal data colon name. So, here we can see that this particular column family name column is identified by the column of the column family name concatenated with the column name using the colon. So, this is the column name, and the column family name is shown over here. This is the column family name. So, this is shown over here. So, column family name and the name will qualify, will identify the particular column. So, column families are mapped to the storage files and are stored in a separate files, which can also be accessed separately. Now, cell in a HBase table, data is stored in HBase table cells, and cell is a combination of row, column family and column qualifier, and contains a value and a timestamp. So, the key consists of the row key, column name and a timestamp that is shown here, and the entire cell with the added structural information is called the key value pair. So, HBase data model consists of a table. HBase organizes data into the table, and the table names are the string composed of the characters that are saved for use in the file system path. And the rows within the table, the data is stored according to its row. Rows are identified by their row key, and row keys do not have the data type and are always treated as the byte. So, this aspect we have already covered. So, column family, the data within the row is grouped by the column family. Every row in the table has the same column family. Although the row need not store the data in all its families, column families are the strings and composed of characters that are safe for use in the file system path. Now, column qualifier, the data within the column family is addressed via the column qualifier, and or simply the column qualifier need not be specified in the advance, and column qualifier need not be consistent between the rows. Like row keys, column qualifier do not have the data type and is always treated as a byte. Cell is a combination of row key, column family and column qualifier uniquely identifies a cell. The data stored in the cell is referred to as the cell value. And timestamp, the values within the cell are version. Versions are identified by their version numbers, which by default is the timestamp. If the timestamp is not specified for the read, the latest one is returned. The number of cell values versions retained by the HBase is configured for each family. The default number of cell versions is 3. Let us see in more detail once again the HBase architecture. So, HBase has this one, a client can access to the H region servers, and this H region servers are many H region servers. One such H region server is shown over here, which has H log, and H region server is divided into different H regions. One such H region is shown over here, and H regions will contain the store and also a mem store. So, within the store it will be having the store files, and store files will contain basic storage that is called H file, and H file is stored in HDFS. Now, as far as there is one H master, and H master communicates with the zookeeper and with the H region servers and HDFS. We will see, we have seen about the H master, and what is zookeeper is a small group of servers which runs a consensus protocol like Paxos, and the zookeeper is the coordination service for HBase, and assigns the different nodes and servers to this particular service. If zookeeper is not there, then HBase will stop functioning. Now, let us see the HBase storage hierarchy. So, HBase has HBase table, which is split into the multiple regions, which is replicated across the servers. Now, then it will be having a column family, which is a subset of the columns with similar query pattern, and one store per combination of column family plus a region is there, and also it has the mem store for each store. In memory updates to store and flush to the disk when full, that like we have seen in the Cassandra. So, store files for each store for each region where the data lives, and within that contains the basic H file, and H file will be stored in HDFS. So, H file is an SS table from the Google's big table. So, this is about the HBase H file. So, H file comprises of data and meta file information, indices and trailer, where the portion data consists of the magic value, key value pairs. So, the key value pair is having the key length, key value length, row length, row and column family length, column family qualifier, timestamp, key value and value. And these rows will have SSN numbers, and column family will have also the demographic information, and column qualifier will have ethnicity information, and this becomes the HBase key. Now, HBase prefers the strong consistency over availability. So, HBase prefers the write ahead log, and whenever a client comes with the key K1, K2, K3, K4 gives to the H region server, then this let us say K1 and K2 will be on a particular H region, and K3, K4 will have on another H region, and then this particular aspect will be stored in the store, and these store will have the mem store and store files, and internally they are stored in H file. So, write to H log before writing to mem store is there to ensure the fault tolerance aspect and recovery from the failures. So, this helps recover from the failure by replaying H log. So, log replay after the recovery from the failure or upon boot up H region servers, and H region master will do the replay. So, replay any stale logs using the timestamp to find out where the database is with respect to the log, and replay will add it to the mem store. Now, cross data center replication. Now, there will be a single master cluster, others slave cluster replicate the same table. Master cluster synchronously sends H log over the slaves clusters. Coordination among the cluster is done via Zookeeper. Zookeeper can be used like a file system to store the control information, and also this particular Zookeeper will use different path for invoking the state and peer cluster number and H log. All this information is there. Now, let us see how the auto sharding is done, and auto sharding means the tables is divided into the row range or range keys, and they are being stored in the region servers, and these region servers are now served with the client. Now, similarly, the table logical view, we can see that the rows are now split into the row keys in the range keys, and these range keys are given sharded into the region servers, and we have shown here that these rows from A to Z are stored in 3 different region servers, and this layout is there, and it is automatically done by, that is called auto sharding and distribution. So, unit of scalability in HBase is the region that we have seen, which is managed by the region servers, and they are sorted and contiguous range of rows spread randomly across the region servers, moved around for the load balancing and failover, that we have already seen in the previous slides. So, split automatically or manually to scale with the growing data, and capacity is solely a factor of cluster nodes versus the region per node. Now, there is a use of BloomFilter here in HBase also. So, BloomFilters are generated when when H file is persisted, stored at the end of H file, loaded into the memory. This BloomFilter will allow us to check on the rows and from the column level, and they can filter the entire store files from the read. Useful when the data is grouped, and also useful when many misses are expected during the reads. So, let us see the positioning of BloomFilter into this H file. So, at the bottom of H file, this particular the BloomFilter information is stored, and this will help in identifying which of these different blocks are basically containing the block index or information. So, using BloomFilter you can access at least at most 2 blocks, not the entire set of blocks sequentially has to be read. So, hence the access is reduced from 6 seeks per block to the 2 seeks per block using the BloomFilter, and BloomFilter is stored as a part of H file. Now, as far as fold, store and shift is concerned, you can see here that for a particular row the same data is stored multiple instances because the time series data is also stored at different time stamp. The data is stored for a particular row key. So, that is why several data on a particular row key is now appearing. They may be varying at their time stamp T1, T2 and T3, and they are stored into the store file. Logical layout does not match the physical one, and here all the values are stored with the full coordinates, including the row key, column family, and column qualifier and the timestamp. Folds column into the row per column, and nulls are cost free as nothing is stored. Versions are multiple rows in a folded table. Conclusion: traditional databases RDBMS works with strong consistency and offers ACID property, and in the modern workload doesn't need such strong guarantees, but do need fast response time, that is the availability. Unfortunately, CAP provides 3 out of 2, that is here given the partition tolerance, the HBase prefers the consistency over the availability. So, key value pair or a new SQL system offers the base property in these scenarios. So, Cassandra offers the eventual consistency, and the other variety of consistency models are striving towards the strong consistency. So, in this lecture we have covered about the HBase architecture, components, data model, storage hierarchy, cross data center replication, auto sorting, distribution, BloomFilter, and fold, store, and shift operation. Thank you.